Kilauea breaks record, 2,000-foot lava tower changes the face of Hawaii in an instant. Normally serene blue Hawaiian afternoon sky suddenly transformed into an apocalyptic canvas. A gigantic lava column, nearly 2,000 feet high, erupted from Kilauea's crater. It rose like a pillar of fire, piercing the boundary between earth and sky. Fiery red light reflected off every surface, turning the tropical landscape into a pulsating sea of hot light. The air vibrated with a deep rumbling that reached the chest, as if the island itself were breathing faster and faster, uncontrollably. This extraordinary event was not sudden. It was the result of long-accumulated magmatic pressure locked beneath the surface. Pockets of magma within Kilauea filled and heated over time, creating extreme pressure. Eventually, this pressure forced its way out through fractures in the rock. The erupting plume far exceeded the average height of previous eruptions. It was one of the most intense events ever recorded in modern history for the Pacific region. More deeply, scientists explain that this phenomenon is closely related to the complex dynamics of the Earth's mantle beneath Hawaii. Volcanic hotspots continually push fresh magma upward through the crust, creating a nearly constant supply system. However, when these flow paths become blocked or compressed, the stored energy can be released explosively, producing lava jets that are not only tall but also incredibly powerful and highly pressurized, as seen in this event. Record-breaking eruption was not simply a height figure. Rather, it was the combination of volume, pressure, and duration that created a rare phenomenon, where lava not only flowed but danced through the air in giant jets, forming arcs of light that seemed almost unreal, and reminded experts of historical eruptions that are extremely rare, even by the standards of Kilauea's high activity. Meanwhile, the impact on the landscape of Hawaii's Big Island was visible almost immediately, as the new lava flow began to form layers of fresh, rapidly hardening rock, engulfing vegetation, changing the land's contours, and even creating new landmasses in some areas, a geological process that, on a human timescale, seems destructive, but from a terrestrial perspective, is part of an ongoing cycle of creation. However, behind the stunning visuals, there are mixed reactions from scientists monitoring this activity through sophisticated instruments provided by the United States Geological Survey. Seismic data, ground deformation, and gas emissions indicate that the magma system remains highly active, fueling concerns that this eruption is not the peak, but rather part of a larger, potentially ongoing cycle. Local residents, on the other hand, watch with a mixture of awe at the incredible power of nature and fear of what might happen next. For many of them, Kilauea is not just a volcano, but a part of everyday life that is now showing its most violent side, forcing them to remain vigilant for possible evacuations or rapid changes in conditions. Furthermore, geologists are beginning to highlight that the current changes could indicate a shift in the pattern of volcanic activity in the region, where increasing pressure and frequency of eruptions could signal a new phase in Kilauea's long cycle, a phase that may bring more extreme events in the near future, though still fraught with scientific uncertainty. Tensions slowly escalated as further analysis revealed that the magma pathway beneath the volcano might be reorganizing, opening the possibility of new vents or even a change in the location of future eruptions, a scenario that could expand the affected area and increase the risk to surrounding communities, challenging existing scientific understanding of the behavior of shield volcanoes like Kilauea. And as the red glow continued to dance through the day, reflecting the heat shimmer off every corner of the island, a major question began to resonate among scientists and residents. Was this just a spectacular event that would subside, or was it the beginning of a new, far more extensive phase of volcanic activity that humans still don't fully understand?